Okay, waves 2, chapter 12. First thing to note, came from the first question. For a diffraction pattern, you need coherent source. Always what I forget, coherent, constant phase difference, which we can imply only really comes from having light or sound or a wave from a single source. So why do we not use two different sources to make a diffraction pattern? Why don't we just use two sources instead of making slits? We need a coherent source and also we need it to diffract. Okay, all this is fine. Remember, path difference between path difference and phase difference. There was one with a AC supply for loudspeakers. You need AC for loudspeakers. Anyway, and I did, and one of them was okay. So it's the connections of one of the loudspeakers is reversed. I did think immediately it's just gonna switch the positions of maximum and minima. I thought let me just draw it to make sure. So did this little diagram of just one wave and then what's going to happen if we do that backwards essentially. So it's going to go like that instead, and therefore you can see if when that superposes it's going to get it's just going to produce a maxima in the opposite place. I didn't explain that very well, but I think you see. Yeah, that's fine. That is the wrong page. The rest of them, blah blah blah. Make sure you say constructive, destructive interference arriving in phase and antiphase, creating bright, dark spots, maxima, minima. This question, which was interesting, the end of question 4, saying that we change the tension on the string, and that changes the velocity of the wave. I got it in my head, oh, we're increasing the velocity of the wave. Well, that means we must increase the frequency, so we're going to have a diffraction pattern where it's we're going to have a wave that's like this, where we have more of this. We make more, and I thought, oh no. So when it increases by a factor of 3/2, you're not going to be able to, but I knew that we kept the frequency constant. It was just how it was in my head. I didn't take in the fact that the wavelength is increasing, which is going to make a less loops in the interference pattern. And then if you increase that by if you decrease that by factor 2/3, you can get you can't see this too tough. You can get enough, you can get multiples of closed loops, which in the system is what works. You need node, antinode, node, so that standing wave will be set up. So yeah, just trying to internalize those kinds of things. Think, I'm increasing or decreasing the wavelength. What is that going to do to the interference pattern? Okay, I didn't mention that something oscillates horizontally. Maybe it's just useful to mention the direction of where something's oscillating. Oh yes, I always forget this. I can think of it when I see the pattern of the loops, that the entirety of that loop is in phase and is pi out of phase with the loop next to it, which makes sense because they're all oscillating with that same frequency. But in a sound wave in a tube, it's sometimes a bit harder to think of, but still within the open end and the closed end, all of this intermediary is still oscillating in phase and with the same time period. The amplitude is changing, but they only have phase difference between the loops. So in phase, antinode, node, in phase, antiphase. Yeah, I hope that makes sense. And I think there's a typo in the last question. The diagram is labelled with 0.28 when it should be 0.6. But that's fine, that's just a numerical thing. Yeah, waves 2. Got this. One more for this topic. Yay.